What's going on? My name's Robert and you are watching Southpaw Auto Works. This video is going to be all about the power flow through the 4L60E. In this video, we're going to talk about the 4L60E power flow. So how the power from the engine goes into the transmission and then out the tail shaft, out to the wheels. Here's what first gear happens to look like. At any rate, before we get into that, let me pull this off of the stand. With this completed stack up off of our stand, let me show you each of the individual components. So here is our output ring gear. Got a bearing here on the backside. Set that down onto the stand, and that'll actually spin, courtesy of that bearing. Next is our planet carrier. Got each of these planet gears or pinions. Also got another bearing here. It drops down. It drops right down into or splines into the output ring gear. And then the last component of our output planetary gear set is the reaction sun gear. Next, we've got our center support. This thing serves a couple purposes. One, it acts as a pressure plate for the low reverse clutches. This clutch back here. And then back to the center support, the other feature that it has is this one-way clutch. So this clutch will spin clockwise and lock counterclockwise. And these lug to the transmission case. And the center support lugs to this carrier. So let's drop that down. And then I've got a screw right here that's run into this stand, and that keeps this center support from moving. Basically to emulate or mimic having this center support in the transmission case, but without having the obstruction to view of the transmission case. In other words, we wouldn't be able to see all this if it was in the case, obviously. Next, we've got a washer that separates the low roller. That's this one-way clutch here is the low roller. That washer separates that from this sun gear shell or sun shell. And I got to get that splined. Let's do this. It splines to the sun gear, the reaction sun gear. Drop that down on there. Next, we've got our reaction hub and input ring gear combination piece here. It drops down in. Then we've got our input planet carrier. And then, last but not least, our input sun gear. And I would have the shaft up through there, but in order to hold it in place, you need a snap ring or it'll just drop out. So I'm not going to do that right now. Speaking of the shaft, there are, out of these, 2 planetary gear sets. So again, this is couple of the components from our front planetary gear set, including the sun gear. Out of that front planetary gear set, only one item splines to the output shaft, and it happens to be this input carrier. It locks right to the output shaft. Got to keep that in mind. And then regarding the rear planetary gear set, see if I can get that out. The output ring gear, it splines to the output shaft. Speaking of splines, the output carrier happens to have splines right down into this bore, and that splines to this front ring gear. Just like so, and now they are one.
This planetary gear set is the heart of the 4L60E automatic transmission. With it, GM was able to create park, reverse, neutral, and 4 forward gears. While this compound planetary gear set is very important, it cannot function all by itself. All of the remaining transmission parts work in concert to assist this planetary gear set. The clutches, the band, the one-way clutches, the valve body, the pump, and so on. Every component is needed. For example, the pump feeds oil to the torque converter, filling it, enabling the torque converter to transfer rotation from the engine to the input shaft. The pump also feeds oil to the clutch packs. In the case of the forward clutches, the feed oil is used to activate the forward clutch and create a mechanical connection between the input shaft and the planetary gear set. Last but certainly not least, the pump provides oil to the planetary gear set to keep it lubricated and cooled. As you can see, all transmission parts play an important role in assisting the planetary gear set.
So you may be wondering, how does engine power actually make it down to this planetary gear set? It's a good question. When you pull this transmission apart, you get the pump out, and then both of these drums come out. You've got your input reverse drum here, which would have a band wrapped around it, and then your input drum. For the first segment of this, we're going to focus just on the input drum. So let's get rid of the input reverse drum and focus just on this input drum. This is splined to the torque converter for the sake of simplicity, making this as easy and as simple as possible, this explanation. Let's just assume that this input shaft spins at the speed of the engine. So anytime the engine's running, whether it's idling or driving on the road, this shaft is rotating at the same speed. Okay? That's not literally the case, but that's what we're going to go with, all right? So this matches the engine speed, whatever it is. We don't need to know what the speed is, but this drum is spinning anytime the engine is running, all right? So now that we know that, this drum has a number of clutches in it, which they're not in there right now. Let me stack some clutches in here so you can see. Normally, the first set of clutches would be these coast clutches. I'm going to leave these out, though, because we don't need this clutch pack in there for this setup. And I'm trying to keep this as basic as possible. The next clutch pack in that housing are your forwards. And these are used for most of the forward gears, as the name implies. So these clutches, this clutch pack, does two things. One part of this clutch pack, all of the steels, they have outer teeth and they lug right into the drum. So as the drum spins, the steels spin with it. They become one with the drum. However, The friction material, they have inner teeth instead of outer teeth, and they spline to a hub. This is the forward sprag, or input sprag. It's designed to rotate one way, then lock the other way. This hub here is for those coast clutches, which we're not going to dive into. And this hub here is for the forward clutches. So naturally, the forward clutches spline right onto that hub. In addition to those clutches being splined to this hub, there's also splines on the inside here, and it splines to this sun gear. So whatever this hub is doing, the sun gear is doing. So let's bear that in mind. So when the forward clutches are applied, and I'm going to throw this input sprag right onto our assembly here, and just bear in mind that it controls that input sun gear, because they are splined together. They are now one piece. It's a little bit crude, but a good use of my arm. Here's your clutch pack. This is the forward clutch pack. When it is not applied or not being used, it's loose. Nothing like this. This is an extreme example, but at any rate, to make a point, you've got your pressure plate here. There's a snap ring. This part does not move in the drum. But then you've got a piston here that compresses all this. When the clutch circuit is turned on, it compresses all this, sandwiches everything together, and now this whole unit, both the outside and the inside, it's all one. It's all rotating together. So bearing that in mind, this clutch pack that is now one with this spinning drum. The forward drum clutch pack kicks on. This drum was spinning before and those clutches were just at rest. They're now spinning. And that acts on this clutch hub, the forward clutch hub. And that will start to drive the planetary gear set. Back to our drum. Our next clutch pack is the 3/4 clutch pack. And again, all of the steels lug to the case. And our friction materials lug to the hub down below the forward one. Just like so. They're lugged there. And just like before, back to our spinning input drum, always spinning while the engine's spinning. Just like before with the forward clutches, the 3/4 clutches behave in the same manner. So when this clutch pack is applied, all of the clutches, the frictions and the steels, they become one. And they become one with the drum that's spinning, so now these rotate too. And that rotation acts on this hub, which is the next hub down in here. Hard to see, but acts on this hub and rotates it so the drum and the hub become one, rotating together. Back to our point of origin, this input drum. I know I sound redundant, but anytime the engine's on and running, this thing is rotating. So back to this drum, let's take a look at this input reverse drum. It lives right on top of the input drum. Here is the input reverse clutch pack. It lives down inside of this drum. And just like the input drum and all of its clutches, you've got the steels that lug to the inside of that drum, and then the frictions have to lug to a hub. Except for this time, instead of it being on the planetary, these frictions lug right to that input drum. So when the input reverse clutch is applied, it makes it so the input drum and the input reverse drum become one and they rotate together. However, when the clutch is off, they can rotate independently of one another. What does this input drum have to do with the planetary gear set? It's a great question. So we've got our drum, which lugs to this sun shell, which splines to the sun gear. This happens to be the output sun gear, or commonly referred to as the reaction sun gear. So when that input reverse clutch pack comes on and it makes this drum spin at the same speed or mechanically locked to that input drum, now all of this spins together. This input drum not only has clutches on the inside of it, but around the outside lives a band. This is the 2/4 band. And it lives around the outside of this drum. So this band wraps around the drum, but the ends of the band actually lug to the transmission case. So when this band is applied, it squeezes this drum and makes it mechanically locked to the case. So the drum stops spinning. And you got to remember, if the drum stops spinning because the band is turned on and it acts as a brake, if the drum stops spinning, it causes the shell to stop spinning, which in turn causes this reaction sun gear to stop spinning. One of the clutch pack that I haven't covered is the low reverse clutch pack. The steel is splined to the inside of the transmission case, all the way at the very back. And the clutches spline to this output planet carrier, like so. And this down here is our planet carrier. And just like always, when those clutches are turned on, they're going to compress and squeeze. And in this case, when the clutch pack is compressed, it acts as a brake. It locks this mechanically. It creates a mechanical connection between this output planet carrier and the transmission case. The transmission case doesn't rotate. This does, and it wants to rotate. But when that low reverse clutch pack comes on, it prevents this from rotating, which has positive consequences for us.
So the low reverse clutch and the 2/4 band both act as brakes. These two particular clutches both prevent parts from rotating, whereas all of the other clutches in this 4L60E transmission are used to create rotation.
So now that we understand how power comes from the engine in through the input drum and how it's distributed, this rotation is distributed from this input drum and how it makes its way into the planetary gear set. Now that we've got that out of the way, let's take a look at a band and clutch application chart. It tells us which clutches need to be on, or which bands, and which one-way clutches are either applied or freewheeling in order to make any of the 4 forward gears reverse or park or neutral happen. So in order for first gear to happen, the forward clutches come on, which act on this hub here, which, if you remember, is attached to our sun gear. At any rate, forward clutches are on and attached to this hub, driving this hub. And at the same time, the low roller is activated. And it's just a dumb mechanical device. It prevents rotation from one direction and lets it freewheel, or lets rotation occur in the other direction. It's not controlled by the computer or by the driver. It's just like I said, a dumb mechanical device, but it does a great job. So for first gear to happen, we need the forward clutches applied and this low roller. And this would normally be lugged to the transmission case. this low roller, the center support, which is attached to the low roller. It would normally be lugged to the transmission case. It's obviously not lugged to a transmission case because it's sitting here on this wooden jig I made, but I do have a screw run into there, and it's just preventing this from rotating. Screws run down into the wood and hooked right to this center support. So that's going to simulate this whole setup being in the case, but we want to be able to see what's going on. So as I rotate this forward clutch hub, just like it would do with the engine running and the forward's on, you can see that the output shaft is rotating. Let me grab some stickers here that I made. Just some tape with some blue paint on there so we can see what the heck's going on. I've got one for our input and one for our output. So for the output, I'm going to stick this blue guy right here on the part gear, which happens to be splined to the, long story short, splined to the output shaft. And I want to get that centered all right here. And right here, and I don't know if you can see those, you can. So the deal with first gear is it's roughly a 3-to-1 ratio. So what that means is 3 revolutions of the input, from the engine, 3 revolutions coming in, and 1 revolution going out. So as I rotate this, I want you to watch this blue tape. We're only going to have 1 revolution. We're only going to have 1 revolution here, but we're going to count the revolutions up here. So here we go. Going clockwise. We've got 1. Still no sign of the output blue tape. We've got 2. We're coming around. We're a little past 2.5, 2 3/4, and here's our blue tape making its way around. It is pretty much 3-to-1. Here's the exact spec that GM calls for. So this is what's called a torque multiplication. It allows us to put more in to get less out. It's great for acceleration, not so good for top speed or fuel efficiency, but that's why the transmission shifts from first gear to second gear. So let's take a look at that. So for second gear, we're still using, according to our clutch and band application chart, for second gear, we're still using the forward clutches. They're still on. And now we're going to use the 2/4 band that wraps around the drum. Here's our drum. Band's wrapped around it. The band comes on. So we got our forward clutches still on, driving everything. The band comes on, and it is a brake and stops us from rotating. All right, so as the forward clutch rotates in a clockwise manner, we're going to hold this sun shell, because the input reverse drum is being held by the band, and it's lugged to this. So we're going to hold this as we rotate, and we're going to count revolutions. We're going to see how many revolutions we get of the input for 1 revolution of the output. And here we go. There's 1. All right, and the output has made 1 whole revolution, and we're past half. So 1.5, 1.6 to 1 is our second gear. So let me reset this, and then let's do third gear. So for third gear, the forward clutches are on. And I'm sorry, I forgot to mention that as we shift gears, some of these gears, they have to, these clutches and bands, they have to turn off. You can't have too many on at once because this thing will bind up and the whole thing will act as a brake. If there's not enough clutches on at any given point, it goes into what's called a neutral. And we all know what neutral is. The engine revs, but the vehicle doesn't go anywhere. So for any gear to work, you got to have typically 2 components on. More on that in another video. This one's going to be harder to see, but we've got tape on our forward clutch hub, and now we've got tape on our 3/4 clutch hub, because for the forward gear to occur, we got to have our forwards on, and we got to have our 3/4s on at the same time. So they rotate together. This is kind of cool how this works. So I'm going to grab both clutch hubs, and I'm going to rotate them at the same time together. And actually, what it does is it locks them together. The planetary gear set, it all locks together and rotates as one. And to prove that, let me take the tape off of our 3/4 clutch hub. I'm going to put it back onto our output. And third gear in this transmission, and in a lot of transmissions, third gear is 1-to-1. So 1 revolution of the input equates to 1 revolution of the output. So let me grab both of these clutch hubs, the forward and the 3/4 clutch hubs, and I'm going to start rotating. There we go. 1-to-1. All right, so now we've got first, second, and third gear out of the way. Now we're going to work on fourth gear. So for fourth gear to occur, the forward clutch stays on, but it really doesn't do anything. That's where this one-way clutch comes into play. It'll freewheel the opposite direction, but I don't want to trail off into the weeds with that. But according to the band and clutch, the clutch and band application chart, the forwards stay on, the 3/4 stay on, and now our band, it turns on again, once again stopping the shell and the sun gear from moving down there. So I am going to put this piece of tape down on our 3/4 clutch hub, and we're going to rotate it while we hold the sun shell. And in this case, we should see less revolutions in, like less than 1 to 1 revolution of this. So this is what an overdrive is. All of our other gears have been 3-to-1, 2-to-1, 1-to-1, and now we're less than 1-to-1 revolution. So this enables, in an overdrive situation, it enables the engine RPM to drop down even lower. So it's great for highway cruising. So I'm going to rotate this while I'm holding the shell. I got to keep an eye on that tape. It's coming around, and it is right there, and yet my other tape is right here. So that was almost 3/4 of a turn, roughly. I mean, this isn't real scientific, but yeah, about 0.75 to 1. So this is how an automatic transmission works. It's all about controlling this planetary gear set. Everything else in the transmission is all designed to assist this. You've got a pump that displaces oil. That oil is used to not only lubricate this planetary gear set, it's also used to apply the clutches. So the power can be transmitted from the engine through this moving input shaft. It can be transmitted from that into the planetary gear set. And then, of course, the pump is also used to operate the torque converter. And without the torque converter, we wouldn't get any power to this input shaft. But point being, all these other items in the transmission, the pump, all of your clutch packs, the band, the one-way clutches, the valve body, I mean, everything. It's all designed to work in concert with or control this planetary gear set.
If you enjoyed this video, please let me know by hitting that like button. I would love to hear from you. Drop me a line in the comment section down below. If you haven't done so already, subscribe, and don't forget to hit that notification bell so you don't miss any future videos. If you're interested in helping this YouTube channel grow, there are a number of ways that you can get involved. Check out the video description down below for more information. Thanks for watching, and I'll catch you next time.